The idea is simple enough. You want to plot a function. You enter it in, well, we'll take a closer look, but math-friendly notation. And then you can do anything you want with it. Here's just a few examples. Here's an example in progress. The important thing is that your function got turned into this nice little path which can be used by so many tools. We're talking real-world tools, graphics tools. It's a nice format. My problem with Desmos, it was great at showing me something, but I couldn't integrate those results into a bigger paper in a nice way. That's why I started doing this. I tried just using Desmos and taking screenshots, but eventually I got sucked into this world of graphics. So there's a lot of examples here. You can make it wider or thinner. Oh my goodness. That shouldn't have locked up, but... Okay, let's take a look at a different example. Circle with a wavy edge. First thing to notice, the quality has dropped a little bit. There's some weird straight lines. So, fortunately, there's a setting for that. You can read more about it, but basically, this is just an approximation, and how many samples are you taking? How many segments are you breaking the curve into? This is an attractive one. So you can reconfigure this in various ways, but for now we're just proving a point. Any function you want can go into here. I don't know why, but I'm not even a romantic. It's just a very nice shape. And I did learn something. I asked the AI to give me the formula for a star, but it cut out the important parts. Apparently the word I was looking for was pentagram. Ah, yes, this is one of my favorites. You can make it narrower or wider. And what are we doing here? So we start with one normal circle, basically. And the next time it intersects with itself, we have 3 lobes. And this is what I was really looking for, was I thought it was a star with rounded corners. It is apparently a pentagram with rounded corners. And again, this shape just can be used in all the regular ways. It doesn't matter which shape you're looking at. Yeah, this, I was originally planning to just make it snap to the exact spots where it repeats. But I found out on accident that it actually looks good as you're going in between those states. So, and if I'm going to pat myself on the back, the fact that the animations keep running while I'm doing this adjustment is kind of impressive. Or let's try a simpler example. Ellipse. Let's see. Let's not even use a slider here. Let's just say the width is always going to be half the height. And that's a comment if you don't know JavaScript. And const is just normal algebra notation. It says the width is going to be this, and you can't say width equals width plus 1. It just doesn't change. And angle. Yeah, this, I was trying to get fancy and prove a point. But let's just say T's our input. T goes from 0 to 1 because that's how things often work in computer graphics. In animations in particular. So I'm saying that the angle will then go from 0 to 2 pi, 0 to 360 degrees. So, yeah, height, width, angle. And hopefully most of the audience recognizes this stuff. Again, if you don't know all the programming stuff, you might not know to add math dot, but this is a pretty simple formula for an ellipse that I hope most of you would have seen before. So again, this is any function you want, any function you can dream of, just punch it into here. And it can actually be more powerful than we're showing here. This is just a quick demo, just a way to get you started without creating a project or writing any serious code. Most of what's going on, if you actually look at the code behind this, mostly it's just centering things and making sure that they fit on the screen and panning and zooming. So if I did something crazy like plus 4,000, what's going to happen? Well, in fact, nothing, because I just moved the camera to follow that. It automatically centers around your thing. And again, that's making it easy just for this demo. In the real world, you probably know what your constraints are. You probably don't need that done for you. So this is the origin, I guess, of my my experiences with SVG and math. I love this decoration at the top. This is actually highlighting some mistakes that I found, and they were nice looking mistakes, so that's kind of the header. Okay, how to divide by zero and other things you will learn in high school calculus. Yeah, I love this paper. I am still recommending it, but today we're just focused on the pretty graphics. You can read the paper on your own time. So here, some of this comes straight out of Desmos, but things like just moving that arrow and that was a fun thing. This was one of the first serious things I was doing with math and with SVG. Yeah, these too. Well, in this case, it's such a ridiculously simple thing, but it did give me these axes and the numbers and the little lines of different weights. So yes, Desmos did a lot of this for me. Yep. Best bibliography ever. You just click on it and click on the picture and it takes you to the source. But anyway, I had to add these things, 3 and 2, and this was again very early in my experiences with SVG. I could probably find some slightly better looking things, but this proves the point very well. And then, oops, once you have SVG, it's so easy to animate. I mean, it's the same tools that are available to you with normal HTML, but you're taking in an SVG, either something that an artist made for you or something that you made with a tool like mine. And well, the inputs are all just numbers. If you're on this channel, you're probably comfortable with numbers. So that's how you make the SVG dance. You just replace some numbers with others. Yeah, again, this at the time I was impressed with myself for doing this, but this was some of my first experiences with this. I do love this. Now, I have to admit, I pulled back on this one. This was originally going to be, it's going to follow the mouse. It was going to be interactive. But that caused some problems, and I had a deadline. This is, I think this was Sum 3, maybe. But yes, there was a deadline. But there you have it. It is zooming in on different spots, and it's zoomed in, and it's completely accurate. This was relatively easy to do. This didn't require any special tools. A parabola is one of the basic things built into the graphics. That's what things are built on top of. My tool basically takes your function and simulates it with nothing but a series of bits and pieces of parabolas. So here it's just one parabola. So it's the easy thing. Yeah, I am very proud of this work. In fact, I've gotten better at doing it and making it work better, making it easier, but the basics were here. I was seeing what I needed to do in this example. There we are. The Harry Potter stuff. Again, this is all pretty trivial, and it took a little bit of time just because I didn't know the tools back then, but yeah, this is what SVG is made to do. Ah, the fun stuff. So yeah, these are just sine waves. This is the sort of thing you could absolutely plot in Desmos, and there's a slider feature, and I think there's even an automation feature, so you could make this totally in Desmos where it's just moving. But the question is, can you integrate it with other graphics, or for that matter, with a document as a whole? So this was kind of my first experience with this what turned out to be an important tool, saying, give me a function and I'm going to spit it out as a path, something that computer graphics and a lot of other things know how to do really well. I don't know why. There's just something satisfying about when the graphics break out just a little bit. I'm going to call that an artistic decision. Yeah, each of these things was hand-coded. Some of them look very similar to one another if you look closely, but let's see. There it is. I don't know how many people notice those little things. It's just, they're just Easter eggs. They're fun to add, and who else do you show? Could be anything. Yeah, that's you got to imagine that I first learned this stuff before graphing calculators were a thing, just a few years before that. And these images have been in my head, these exact things, these ideas of, the area under the curve. And now suddenly it's all graphics that are available to everybody. And I really love my summary here. I don't know. Maybe I just love bullet points and summarizing things. Well, thanks for taking a look. These are just some samples. The tool is available, and let me know if you need help using it.